Hello everyone, welcome back to ChemOrgChem. So today we are going to explore Caglioti reaction and their modification. If you are new here, don't forget to subscribe and hit the bell icon for notification. Let's move into the Caglioti reaction. So first, what is mean Caglioti reaction? This reaction is related to Wolff-Kishner reduction where we need strong base, hydrazine and higher reaction temperature that restricts the use of Wolff-Kishner reduction. So therefore, milder reaction conditions are evolved one by one. Caglioti reaction condition, tosyl hydrozones reduced by their corresponding hydrocarbon is known as Caglioti reaction. So this is the general scheme of Caglioti reaction. So as per this reaction, initially carbonyl compound react with para-toluene sulfonyl hydroxide and followed by that react with hydride base that produce their corresponding hydrocarbon. In case of hydride base, there are several hydride base can be useful for this transformation such as diborane, lithium hydride, sodium borohydride, lithium aluminum hydride, sodium cyanoborohydride and catechol borane. So let's see their mechanism, how this reaction works. So initially, carbonyl compound react with para-toluene sulfonyl hydroxide that produce their corresponding tosyl hydrozones. Now these tosyl hydrozones react with suitable hydride base. In general calculative reaction, we need lithium aluminum hydride which act as a base as well as a reductant. So now you can see that lithium aluminum hydride initially acts as a base that takes the proton from this NH, so resulting that produce this corresponding intermediate. Now another hydride ion coming from lithium aluminum hydride that attacks this imine carbon, so resulting that this pi electron shifted towards here, then this para-toluene sulfonate ion kick off which produce this corresponding intermediate. So now this negative charge move towards here, then followed by cleavage of this carbon nitrogen bond, so which produce their corresponding carbon ion as well as elimination as a nitrogen gas. So when we do workup, that produce their corresponding hydrocarbon compounds. However, under this reaction condition, when we use carbonyl compound contains alpha hydrogen that produce some of the side products. So let's see what side products usually observed because of basicity of lithium aluminum hydride. So when we use this class of carbonyl compound which having alpha hydrogen atoms that usually produce alkene compound. So this reaction is related to Shapiro reaction. So let's see how this reaction works. So now you see here lithium aluminum hydride which react with their corresponding tosyl hydrozones. So now this lithium aluminum hydride that produce a hydride base, that hydride base readily takes the proton from this alpha carbon, then followed by this electron shift here, this pi electron shift towards here, which kick off para-toluene sulfonate ion, which produce this corresponding intermediate, then kick off nitrogen gas. So that produce their corresponding alkynyl carbon ion, so which then readily takes the proton from solvent that produce alkene product. Sometimes if we use excess of reducing agent, we could observe alkane compound also. Therefore, this is one of the disadvantage of calculative reaction. So in order to overcome these shortcomings, so there are several modifications also known. So let's moving on. Some of the examples of Caglioti reaction. So this is the first example. So now you see this ketone initially react with para-toluene sulfonyl hydroxide ethanol under reflux which produce their corresponding tosyl hydrazone. That tosyl hydrazone can be reduced by lithium aluminum hydride that produce their corresponding alkane compound. So this is our second example. So now you see this one is a tosyl hydrazone. So here dibol H act as a hydride base that produce their corresponding alkane compound. So this is the third example. So now you see this ketone initially converted into their corresponding tosyl hydrazone and followed by reduction with sodium borohydride that produce their corresponding alkane compound. Fourth example, now you see So this tosyl hydrazone can be reduced by using lithium aluminum hydride that produce their corresponding alkane compound. So let's moving to the this Caglioti reaction, how it works in case of alpha beta unsaturated compound. So when we treat alpha beta unsaturated carbonyl compound with para toluene sulfonyl hydroxide that produce their corresponding product with alkene transposition. So let's see their mechanism. So initially which react with lithium aluminum hydride. Now you see this hydride ion attack this imine carbon. So now this pi electron shift here. So then that readily abstract the proton from medium. So which produce this corresponding intermediate. Now kick off para toluene sulfonic acid, so which produce this corresponding diazine intermediate. So after the generation of this diazine intermediate which undergo 1,5 sigma tropic rearrangement. So now you see this hydrogen atom coming with electron that adds into this carbon. Now this pi electron shift towards this carbon, so resulting that kick off nitrogen gas, so which produce this corresponding product with alkene transposition. So now you see alkene shifted from this carbon to this carbon. However, this reaction also has some of the disadvantages. For example, so this reaction is we need to conduct under basic conditions. So when we conduct this reaction under basic conditions, sometimes we observe some of the side product. For example, so when we treat this tosyl hydrazone with sodium borohydride under basic condition, that usually produce this type of substitution product. In case of especially alpha beta unsaturated tosyl hydrazone or aromatic tosyl hydrazone, sometimes that may produce this pyrosol type of the product by 3 plus 2 cycloaddition reaction. Therefore, overcome this issue, Hutchins introduced acidic condition for this reaction. So as per Hutchins modification, so when we take the alpha beta unsaturated tosyl hydrazone, that can be reduced under acidic condition by using sodium cyanoborohydride that produce their corresponding product. So let's see their mechanism. So as per Hutchins modification, so initially this alpha beta unsaturated tosyl hydrazone so react with acid. So because of this acid, so that readily protonate this nitrogen atom which produce this corresponding intermediate. Now hydride ion coming from sodium cyanoborohydride that attacks the iminium carbon, so resulting that this pi electron shift towards this nitrogen atom, so which produce this corresponding intermediate. So just now we seen that previous mechanism, so most of the steps are similar. So here also the elimination of para toluene sulfonic acid happen, so resulting that produce this diazine intermediate. So now this diazine intermediate undergo 1,5 sigma tropic rearrangement to produce this product with alkene transposition. Let's see some of the examples for Hutchins modification. So this is the first example. You can see that. So this one is alpha beta unsaturated ketone. So which initially react with para toluene sulfonyl hydroxide in the presence of para toluene sulfonic acid under ethanol. So which would give their corresponding tosyl hydrozones. That tosyl hydrazone reacted with Hutchins modified reaction condition, so that readily reduced that corresponding tosyl hydrazone which produce this corresponding product with alkene migration. So here apart from that, we should note it down the stereochemistry of this aryl ring system. So the stereochemistry of aryl ring system, so here present at the bottom phase, so which means that the hydrogen atom should transferred by top phase. So how this happen? So just imagine that, so the first step of the reaction in Hutchins modification, which is hydride ion. attack the tosyl hydrozones. So due to the steric effect, the initial hydride attack takes place by bottom phase. So therefore, this diazine part come to the top phase. Therefore, the hydrogen atom transfer takes place by top phase, which leads to produce this corresponding product. So let's moving on another example. So now you see, so this ketone can be reduced by sodium cyanoborohydride and para-toluene sulfonic acid condition. So initially we need to convert this ketone into corresponding tosyl hydrazone and followed by treatment of Hutchins modification condition which produce their corresponding hydrocarbons. So this is the another example. So this example confirms that so initial sodium borohydride addition definitely takes place by 1,2 addition rather than 1,4 addition. So as per this condition, you can see that deuterium now incorporated in this position, which means that initial hydride addition takes place this 1,2 position. So when we use sodium borodeutrate, so now deuterium incorporation takes place in this carbon. So similarly, so when we conduct this reaction under sodium borohydride and deuterated acetic acid, so which also confirms that so this initial addition takes place by 1,2 addition manner. So now you see, so initially when we use deuterated acetic acid that readily protonate this nitrogen atom. So now deuterium atom transfer to this carbon by 1,5 sigma tropic rearrangement. So therefore we are getting deuterium incorporation in this carbon. So let's moving on Caglioti reaction modification. So another modification by Kabalka modification. So under Kabalka modification, so when we treat tosyl hydrazone with catechol borane sodium acetate, which also produce their corresponding hydrocarbon compound. So this condition also relatively mild reaction condition in order to convert tosyl hydrazone into their corresponding alkane compound. So let's see their mechanism. So initially this tosyl hydrazone reacted with catechol borane. So here what happened? So initially hydroboration reaction takes place to produce this corresponding intermediate. So now you see this hydrogen atom ordered here in case of this boron unit ordered into their nitrogen atom. So now sodium acetate react with this intermediate. Now this acetate ion attack this boron atom. So resulting that produce their corresponding boron 8 complex. So now this boron 8 complex quickly collapsed. Now you see this boron nitrogen bonded electron now shift here. So resulting that kick off para-toluene sulfonate ion, so which produce their corresponding product and followed by elimination of nitrogen gas which produce their corresponding hydrocarbon product. So let's see some of the examples based on Kabalka modification. So this is the first example. Ketone can be converted into their corresponding alkane product by using catechol borane and chloroform under sodium acetate condition. So this is the another example. So initially this alpha beta unsaturated ketone react with para-toluene sulfonyl hydroxide and followed by react with catechol borane under sodium acetate basic condition which produce this corresponding product with alkene transposition. So here we need to look about the stereochemistry of this particular hydrogen atom. Now you see this hydrogen atom present at the top phase. So which means that so this reaction undergo by this particular transition state. So now you see this hydrogen atom coming from this catechol borane. So remaining units present at the top phase, then followed by this hydrogen atom transfer through 1,5 sigma tropic rearrangement, so which takes place by top phase, so which result that produce this corresponding product. So let's moving on another example. So this is the another example. This one also alpha beta unsaturated carbonyl compound. So when we use Kabalka modification condition which produce their product. with alkene transposition. We have seen that what is mean calculative reaction and their advantages over then Wolff-Kishner reduction, and followed by we seen two type of the modification. So one is Hutchins modification and another one is Kabalka modification, and we seen that various examples of this particular reduction reactions. So if you have any doubt about calculative reaction, so you can leave the comment below. So if you enjoyed this session, just give it a thumbs up and share it with your friends, and don't forget to chem or